Okay, we're going to do lesson 5-5 here, inequalities in triangles. This first guy is a corollary talking about exterior angles and interior angles. This is an exterior angle, and angle 2 and angle 3 are remote interior angles in this picture. And what they're saying here is normally we would say angle 1 is equal to angle 2 plus angle 3. Well, the measurement of an exterior angle is greater than the measurement of each of the remote interior. So this hopefully makes common sense. If this big obtuse angle is equal to 2 plus 3, then that would mean angle 1 here on the outside, that exterior angle, must be greater than angle 2. And also angle 1 must be greater than angle 3. I mean, since 2 plus 3 equals the 1, 1 is going to be bigger than each one of those angles on their own. Let's move to theorem 5-10. If two sides of a triangle are not congruent, so we don't have equal measurements here, so let's go, I don't know, let's put a 7 here, and x, y, I'll put the number 4. Obviously 7 and 4 are not equal. Then the larger angle is opposite the larger side. So in this picture with the 7 and 4, since 7 is greater than 4, the angle that made side 7 is angle y, because if I look at angle y here, it hits the 7. If angle y gets bigger, then the 7 would get bigger. So it's the y and the 7 inches here are related to each other. It is opposite the y. So angle y is greater than the side that is opposite the 4, which is angle z. Theorem 5-11 is pretty much the same idea. Bigger angles will make bigger sides, smaller angles will make smaller side length, and this is just kind of in reversed. I've got two angles of a triangle that are not congruent. So maybe I'll say this is 100 degrees here, and this B is 30 degrees. Obviously, they're not equal. Obviously, 100 is bigger than 30. If you don't have equal angles, then the larger side is opposite the larger angle. Opposite the larger angle. So with this picture here where I put 130 degrees, angle A is clearly bigger than angle B, so that means the side opposite the 100, which is BC, has to be greater than the side opposite the 30 degrees, which is AC. I mean, physically you can tell that it is, but also the opening, the bigger the opening, the bigger the side length opposite. The smaller the side length. Okay, 5-12, this is kind of basically, do you really have a triangle or not? The sum of any two sides of a triangle is greater than the third side. Now what they're saying here is, and I'm going to put some numbers in this triangle, let's say this is 4, this is 6, and this is 7. Any two sides, whether it's 4 plus 6, has to be greater than the third side. 7 plus 6 has to be greater than the third side. So any two, like 4 and 7, has to be greater than that third side length. And that's what they're saying. If two of the side lengths are not greater than this, then actually you wouldn't have a triangle. Alrighty, let's go to some of the problems here. Let's actually skip to number 3, which talks about this theorem right here. They're basically asking, do you have a triangle with these measurements? A 2-inch line, a 7-inch line, and a 9-inch line. Well, again, two of the side lengths must be greater than the third side length. So if I look at 2 and 7, 2 and 7 is equal to 9. It's actually not greater than 9. So is this a triangle? This would actually be no. If I actually drew something that was 9 inches, drew something that was 7 inches, and drew something that was 2 inches, there's no way this thing would pick up to make a triangle. It would just, 7 and 2 would lay right flat on the 9. Would this make a triangle? 4, 6, and 10. Well, the two smaller numbers, 4 plus 6, is greater than 9, so yes, this is a triangle. Okay, you can take a ruler and make a 9-inch line, a 4-inch line, and a 6-inch line, and the 4 and the 6 will meet each other. It's big enough to touch. All right, let's go back to number 1 here. 1 is kind of an odd question here. They're going to give you 3 statements, statement A, B, and C, and there are 2 of them will contradict each other. They just don't really, you can't be in the same sentence. So let's just read this. FG is parallel to KL, FG is perpendicular to KL, FG is congruent to KL. 2 of these concepts cannot be exist at the same time. You cannot be parallel and perpendicular at the same time. So A and B contradict each other. Those are the ones that you just can't be parallel and be perpendicular 90 degrees with each other at the same time. You can be parallel and equal. You can be perpendicular and equal, congruent, but you can't be parallel and perpendicular. Let's see here. List the angles from smallest to largest. So there's angle A, B, and C. Now, the way you can figure out what is the smallest to largest is by looking at the side lengths. The smallest side length is 18 inches. The angle that made the 18 inches look across the triangle, it is angle A. That is what made the 18 feet. Excuse me, not inches. If angle A opens up, that 18 would grow. If angle A squeezes in, that 18 feet would shrink. So angle A being the smallest of the 3 numbers, that's the smallest. 21, angle C is the middle, and then 27 is the biggest, and the biggest angle was created by angle B. Okay, number 4. A triangle has length 3 and 12. Describe the possible lengths of the third side. This guy kind of refers back to the fact that 2 of the sides have to be greater than the third side. So we're not going to have one exact number. We're going to have this range. So imagine a triangle that's 12 feet, 3 feet, and you need to figure out, well, what's the length of this guy here? I'll call it X. It's got to be big enough to reach the 3. It's got to be able to get to 12. So really 3 plus that unknown X has to be greater than 12. If it's too small, like the number 4, 3 and 4 is not going to reach 12. Well, when I minus 3 the other side, X has to be bigger than 9. Has to be bigger than 9 inches. Otherwise, it wouldn't reach. And then you've got to consider it this way. You could imagine, in this example, I made 12 the biggest number, but let's imagine we've got a 3 here and a 12 here. How big is this side length here? We can't have this, the biggest side length be 100, because 3 plus 12 would not reach 100. So you got to look at it like this. 3 plus 12 must be greater than the longest side X. 3 plus 12 is 15. So 15 has to be greater than X, or X has to be less than 15. X cannot be too big. If it is too big, then the 3 and the 12 will not reach it. So it has to be bigger than 9 and less than 15. And that's your range. Anywhere between 9 to 15, and then you would have a triangle.